So your circle and your ellipse are all points that are equal distance from the foci, and this time it says foci instead of focus because I missed it, darn it, because there are two foci instead of one. So just like the parabola, where the focus was surrounded and protected by that parabola, the foci in an ellipse or a circle are also surrounded and protected by the ellipse, so the foci are going to be inside that circle or that ellipse. And so we have two different standard equations for an ellipse. They look extremely similar. What's the difference between them?
A squared.
Yeah, focus on where the a squared is. Wherever the a squared is, that will tell you something about what's called the major axes. If the a squared is below the x, doesn't the x-axis go in this direction, which is a horizontal direction? If you think about an ellipse is a squished circle, so there's always, if I were to put two perpendicular lines through an ellipse, one of those lines is going to be longer than the other. And that's called your major axes. And so if A is underneath the x squared binomial, then your major axis is going to go in the direction of the x-axis, which is horizontal. So you're going to want to write here major axes is horizontal. That is a really important characteristic that you need to learn. If you're not going to memorize the equations, which I don't suggest, well, you do have to memorize the general form of the ellipse. But if you're not going to memorize the general equations for foci and vertices, you have to know that the major axis is horizontal when it's underneath the x squared. And so when it's underneath the y squared, the y-axis is vertical, and so that means that your major axis is going to go in a vertical direction. So for this one, major axis is vertical. Todd, would you mind closing that door for me, please? And the question begs, well, how do I know what's a squared and what's b squared? Because you're going to see numbers. You're not going to see a squared or b squared. You're going to see a number like 20 or 36. And so you need to know which is which. A squared is always greater than b squared. So the bigger of the two numbers in the denominator is always a squared. So for chuckle's sake, we're going to draw a sketch, and we're going to make the assumption that the center is at 0, 0. And so then I want you to go 6 units to the right, 6 units to the left, 3 units up, and 3 units down. And then we're going to plot points. The points, now remember we said our major axes for this one's going to be horizontal, and so technically these are called the vertices. I feel that there's always 4 vertices, but if MathXL asks you for the vertices and they only give you 2 ordered pairs, it's always the vertices on the major axes. But these are vertices on the minor axes. But I'll only label the ones that are on the major. And then you want to connect those so that it looks like Arnold's head, right? Like a football. Try to make it curved, as best curved as you can. Not too bad. And then in addition to that, we're going to have foci. So we're going to put our foci 4 to the right and 4 to the left. These foci are the same distance from the center, right and left, just as the vertices are the same distance from the center, right and left. Now, if I took a squared and took the square root of that, that is the distance from the center to the vertex. A is the distance from the center to the vertex. Whereas if I took the square root of b squared, I got b. B is the distance from the center to the minor axis, if you will, vertex. And so it's always half that distance. So as you look below here, we're going to fill out a few things. So your major axis will be equal to 2a. Your minor axis will be equal to 2b. Your center, in general, is always what? In this case, it's 0, 0, but in general, it's what? HK. And then we have this lovely thing here, which looks like what? It looks like the Pythagorean Theorem, but what's different about it? It's got a minus in there, so it's not quite the Pythagorean Theorem. It's called a Pythagorean relationship. And we use that to find what's called C. Well, C is the distance that the focus is from the center. And so here's your formulas if you care to memorize them. So I'm going to give you the formulas for the vertices. And it changes whether the major axis is horizontal versus vertical. So for the vertices on this one, now I don't memorize these. I just graph and count. But if you want to, again, here they are. So since our vertices on the major axis for this one go horizontally, it's going to affect the x value. So we've got h minus a, because a is the distance from the center to the vertex, comma k. Or h plus a, comma k. And then your foci, also are along that major axis, so they're also they also affect the x value of that center. And so your foci become h plus c, comma k, and h minus c, comma k. Now c we can get from this Pythagorean relationship here. If I know a squared and I know b squared, we just subtract them, and that gives us c squared. And then I can take the square root of that, and that's c. And that c is represented by the distance that the focus is from the center. And what you might want to add here, let's get a good pink. Your foci lie on the major axis C units from the center. And then we have this thing called eccentricity. And all eccentricity is, E for eccentricity, is equal to C divided by A. And eccentricity measures the ovalness of an ellipse. So I'm going to let you explore what that means. And typically we like to look at the eccentricity in its decimal form because oftentimes in this fraction you can have a square root in there. And it's hard to compare different eccentricities from different ellipses if they have different denominators in their fractions or if they have a radical in there. So if you convert it using your calculator to a decimal, then you'll start to see what happens as the ellipse becomes more circular, what happens to the eccentricity, and then what happens to the ellipse as it becomes flatter, what happens to that eccentricity. So in other words, what happens as A and C approach each other or get away from each other. All right, so let's go ahead and sketch when the major axis is vertical. So for this one, I want you to, well, we're going to plot our center first. So your center, again, is at the origin. So there's your center. And then we're going to go 6 up and 6 down and 3 to the right and 3 to the left. And so we're going to plot our vertices at those points. So this is a vertex because it's on our major axis, vertex, and then these are the vertices on the minor axis. And then combine those so that, or connect those so that it appears to be elliptical. I almost had it. There we go. So an ellipse should not look like an egg. It shouldn't have, along the major axis, it shouldn't have one side is visually smaller than the other side. An egg is not an ellipse. It's an egg. All right, then for this one, because our vertices are going vertical this time, it changes the formula for the vertices. So the vertices on this one, they're still affected by A, but it's the y value of the center that's affected. So we have h, comma, k plus a, and h, comma, k minus a. And then your foci are also affected. They only affect the y value of the center. So we have h, comma, k plus c, and h, comma, k minus c. Yes?
How do you know when to do plus c and minus c?
Because you always go right and left and or up and down. Always.
Oh, okay. So left and down.
Yeah, because you always have 2 vertices on either side of the center and 2 foci on either side of the center.
Oh, okay.
And what you need to know is that A goes with the major axis. So A is half the distance from the center to that major axis. It's that half distance. And then B is half the distance, so from the center to the vertex of the minor axis. And then C is always the distance from the center to the foci. Everything is always the distance from the center. Always. It's never the distance from the vertex. And that's the mistake that some kids will make. All right, so let's look at example 1. We're going to graph. We're going to find the center, the 4 vertices, the foci, and the eccentricity. So the first thing that we should note is what?
The center.
Even before the center. Where a squared is. So which one is a squared, the 25 or the 16?
25.
The 25. And since the 25 is below the x, and x goes in this direction, what is the direction of our major axis? Horizontal. So that's the first thing that I note, is that the major axis, because that has to be high in my mind, especially the way I teach you how to do these, because we go by graphing. You've got to bear in mind what the major axis is. So the major axis is horizontal. Then we're going to find the center. So step 2, bless you, what's the center? So the center is 1, 2, h and k, right? So plot that point and label it as C for center. Then I always want to plot my major axes first, always. And so step 3, I'm going to find A and B. Because A is going to be my major axis. So let's start with A. I know that A squared is equal to 25 from above. So what does A equal? 5. So that means that I want to go up, down, or right, left with that 5 if my major axis is horizontal. Right, left. So we're going to go right, left. So we're going to plot those vertices, 5 to the right. I'm going to label that with a V, and 5 to the left. Label that with a V. Then you want to name those. So what are those ordered pairs? What's the vertex on the right? What's its ordered pair? So it is 6, 2, and the one on the left?
Negative 4, 2.
-4, 2. So those are 2 out of the 4 vertices. Then we're going to find B. And I know that B squared is equal to 16. So what is B? 4. And since B is my minor axis, do I want to go up, down, or right, left? Up, down. And it's always from the center. So I'm going to go 4 up. And 4 down. And then I'm going to connect those as smoothly as possible.
So you only label the vertices, you don't label.
Yeah, typically you'll only because I view them all 4 as vertices, but I want you to understand that in Math Excel, if they ask you for the vertices and they only give you 2 options, that those are the main vertices.
So find the vertices of A.
Yeah. But we still have to find the other vertices in order to make the ellipse.
Yeah.
And then we're not quite done because what are we missing?
Foci.
Yep, we need to find the foci. So then step 4, foci. What do I need to find the foci? Very good. So c squared is equal to a squared minus b squared. I've got to find c because the foci are c units away from the center. And so I already know a squared and b squared. I don't have to use a and b because I know a squared and b squared. And so that's what we're going to plug in here. We're going to replace all of a squared with 25 and all of b squared with 16 because I already know those. If you want to use a and b, you can, but you can shorten it up by doing that. And so I've got equals minus my a squared is 25 and my b squared is 16. This should never come out to be a negative answer. If it is, you did it backwards. So what does c squared equal? 9, and what is c? 3. So that means we're going to go 3 up, down, or right, left? Right, left, because our major axis is horizontal. So we are going to go right, left of the center. Always of the center. And so 3 to the right puts us right here. Label it with an F. And 3 to the left. Label that with an F. And so then we want to name those ordered pairs. So what's the ordered pair on the right? 4, 2. And on the left, -2, 2. And then finally they want eccentricity. True? So let's find that. And then we're going to compare it to the last oval. Wouldn't you say that this, or the last ellipse, wouldn't you say that, or we'll compare it to our next one on the next page. This ellipse is almost circular, isn't it? The major and the minor axes are not too far apart from each other in length. And so it's almost circular. Not quite, but almost. And so our eccentricity, E is equal to C divided by A. So our C we found above was 3. And our A we found earlier was 5. So that can be good enough right there. Or you can look at it in terms of its decimal equivalency, 0.60. And we're going to look at that for a reason in a minute. So it's like 60%, if you will. Okay, so questions on that before we go to the next page? Yes?
When it asks for foci, do you want C equals 3 or the ordered pairs?
I want the ordered pairs. If they're asking for the foci, it'll be the ordered pairs. So the C just means the distance. So yeah, definitely label those. And then I would expect that you're labeling on the picture like I've labeled, and then you have your foci off to the side. And notice that if I were grading this, I know that these are my foci because I've labeled it under foci. But if you just have a bunch of ordered pairs everywhere on your paper, am I going to know what ordered pairs are vertices and what are foci? No. So you have to make sure that you label them in some format, somewhere. Okay, any other questions before we move to the back? All right, so let's flip it over. What's the matter with example 2? It's not remotely in proper form. So what we're going to do is pair up the x terms, and we're going to pair up the y terms. I want those to be together. And then we're going to switch. I'm going to make this 31. We're going to make it a positive 4. You'll thank me for that later. So change that 31 right here to a 4. So then I'm going to color code everything. So I have 9x squared minus 36x. Then we're going to have a plus blank. Why? We're going to have to complete the square to get a squared binomial for that formula. And then plus 4y squared plus 8y plus a blank equals, and then I'm going to move that plus 4 to the right by doing what? Subtracting it. So then I have a minus 4. Then I have plus a blue blank and plus a green blank. Because whatever I put on the left, I have to put the identical item on the right. Now, there is a problem with completing the square here. Does anybody remember what the issue is? You cannot have a coefficient from your squared term, even if it makes this one a fraction. You have to factor it out. So we are going to factor out in front a 9, and that gives us x squared minus 4x plus blank and parentheses. Then we're going to factor out the 4 plus 4 times y squared plus 2y plus blank equals, here's the issue. I have a negative 4 plus, I'm running out of room. Whatever I put here, technically, shouldn't it be multiplied by the 9? Do you recall that with completing the square? If you have something out in front of the parentheses, then over here on the other side, you better have 9 times that blank. And so then we're going to have a plus 9 times a blank. And then also, I'm going to have to account for the 4 in front of here with that blank. So I'm going to have a 4 times a blank there as well. That maintains your equality. So then we're ready to complete our square. So for the first parentheses, I'm going to take my 4, and you can do a negative 4 if you want to, it doesn't matter. Divide it by 2 and square it. What do I get? What do I get? 4. So I'm going to add a 4 here, and I'm going to add a 4 here to that 9 being multiplied. And then with the green, I'm going to take the 2 and divide it by 2 and square it. What do I get? What do we get? 1. And so I put a 1 here and a 1 there. Then all you're doing is the math. So we've got 9 parentheses squared. Then you're going to take the square root of your bookends. Square root of x squared and square root of 4 are x and 2. So I get an x and a 2. What's the sign in the middle? Whatever the sign of your middle term is, that's the sign that goes in the middle. So we have a minus. Let me make sure that's obvious. And then plus 4 times parentheses squared. Again, you're going to take the square root of your bookend, so the square root of y squared and 1 are y and 1. And then what's the sign in the middle? Plus, because the sign of your middle term above here was positive. And then equals negative 4 plus 9 times 4 is 36, plus 4 times 1 is 4. And what happens to the 4's? The 4's cancel. And so what we're really left with is 9 times x minus 2 squared plus 4 times y plus 1 squared equals 36. That's why you're going to thank me. Because you notice that the 9 and the 4 here are factors of 36. Now flip your paper over and tell me what you notice about the general form of the equation of ellipse on the right-hand side always is what? 1. So no matter what is in front of the parentheses, this doesn't matter what's in front here. What matters is what this number is here. Whatever that number is, you're going to divide all terms by it. So because that number is 36, we're dividing this by 36 because the right side has to be 1. And then this gets divided by 36, and this gets divided by 36. The nice thing is that the 9 here does cancel into the 36 4 times. If it doesn't, you might actually be left with a coefficient in front of those squared binomials, which we could deal with later. I tried to choose questions in Math Excel that wouldn't happen with, but again, I can never tell sometimes what their similar examples are going to be. And then this 4 cancels into the 36 9 times, and of course those cancel. So your actual general form is x minus 2 squared divided by 4 plus y plus 1 squared divided by 9 equals 1. And so this becomes your equation that we find everything from. So from there, we're finally ready to graph. That was the hard part. So what do I look for first? For what? Before the center? I want a squared, right? So 9 happens to be again underneath the y, so that means that my major axis is what? Major axis is vertical, right? It goes in the direction of the y-axis because it's underneath the y. Then we can look at our center. So step 2, what's our center? Positive 2, negative 1. Opposite signs of what you see in the parentheses here. So let's plot the positive 2, negative 1, and label it as C for center. And then we want to find our A and our B. So I always like to find A first. So my A squared is equal to 9. So what's A? 3. Does that mean I'm going to go right, left, or up, down? Up, down, because my major axis is vertical. So I'm going to plot 3 above, label that as V for vertex, and 3 below the center, and label that as V for vertex. Oh, it's a little hard to see up there, sorry. And then name those ordered pairs. What ordered pair is above? So we have 2, 2. And what ordered pair is below? 2, negative 4. So those are your 2 major axes vertices. That's the distance. If they asked you for the distance of the major axis, then you would do 2 times A. And the distance of the minor axis is 2 times B. Does that make sense?
Yeah.
But A is only the distance above or below or right or left of the center, depending upon where your major axis is. So the only time I ever use 2A is if they give me the length of the major or minor axis, and I'll use that 2A or 2B to find A or B, because then that tells me where I'm counting. And we'll use that here shortly. Isaac, are you okay? What was that? A is always the bigger of the two. A can switch. A squared can switch. A squared is not always below the x squared value. So remember that A squared is always the bigger of these two denominators. And so that's why in this case A squared is 9. Was that your question?
Yeah.
Yep. So make sure you write that on the front, that A squared is always greater than B squared. And then we just have to remember that. All right, so then B, we've got B squared is equal to 4, and so B is equal to 2. And so is that going to be up, down, right, left? Well, it has to be the opposite direction, right? So right, left. So we're going to go right and left of the center 2. So right 2 and left 2. And name those ordered pairs. What's the ordered pair on the left? Be careful with that one. On the left, 0, isn't it -1? 0 first. And then on the right, what's the one on the right? 4, -1. And then you're going to connect those as best you can. What's missing? The foci, right? So we're going to find the foci. What do I need to find the foci? Yep, so c squared is equal to a squared minus b squared. I know a squared and b squared just by looking at the denominators. So I'm going to use those and plug in. So my a squared is 9. And my b squared is 4. That means that c squared is equal to 5. So what is c? The square root of 5. So this one becomes difficult in the sense that we've got to plot the square root of 5 as being square root of 5 above the center and square root of 5 below the center. Well, that's a difficult distance to plot. So my deal with you is this. You have to find the two integers that the square root of 5 is in between. And so think very carefully. What perfect square is to the left of 5, smaller than 5? Perfect square would be 4. Square root is 2. And we'll use that in a minute. What perfect square is to the right of 5? 9. And so that means that this is between 2 and 3 units, right? And so you're going to go between that, you're going to go 2.5 above C and 2.5 below C. And then you're going to have to name those ordered pairs, and that's where the difficulty lies. So we're going to go 2.5 and name that the foci, so F, and then 2.5 below. Now the difficulty is naming those ordered pairs. It's always from the center. So from the center, what part of the center ordered pair changed when I went up and down? Is that the x value or the y value? The y value. So that means that if I were to determine what that ordered pair is there, I'm still going to the right 2, which is the same as the center. So we're going right 2. But then think of it this way. We went from the center, and isn't the y value of the center at -1? So we went from -1 and we went above square root of 5. So that's the exact answer. 2, -1 plus radical 5. And then the other one went to the right 2, and then again from the center at -1 we went down, so minus the square root of 5. The same thing can occur when you're naming your vertices here. If A or B is a radical, you're going to do the same thing. But when you name these vertices, you'll name them again from the center. And you'll have to determine, did I go right, left? Well, that's affecting the x value of the vertex. So you'd add that radical and subtract it from the x value of the center. And if it's going up or down, then it would be affecting the y value of that center, and you'd be adding and subtracting from that y value, just like we did here with the focus. Yes?
Say again how you got those points.
So you know how I got the square root of 5, right?
Yeah.
And you're okay with between 2 and 3.
Yeah.
So then to actually do these ordered pairs, because I'm going up and down, which is it affects the y value of the center, right? Because I went to the right too, but then from the center I went up and down. So we always went to the right too, but from the center of the y value at -1, didn't I actually go up radical 5, which was that 2.5, right? But I want the exact answer, so we're going to use radical 5. Then from that -1, we went down or subtracted radical 5, which was that 2.5.
Where's the -1 coming from?
The -1 is the y value of the center, because that's where we started to go up and down from, was at -1.
Oh, I see.
Does that make sense?
Yeah.
So it's always from the center. So if our major axis had been along the x-axis horizontally, then we would be adding and subtracting that radical 5 to the 2, because we would have gone right 2.5, left 2.5. So that's the hard part that you guys are going to have to play with a little bit. Okay, then the last thing they want is what? Eccentricity. So 5, eccentricity. So eccentricity is equal to C divided by A. So my C, we found, was the square root of 5. And our A, we found earlier, was 3. So you're going to have to use your calculator and just divide the square root of 5 by 3. And actually, it turns out to be an approximation. And the reason why is I want to be able to compare this to our last eccentricity. And so this turns out to be about 7.7454. So is it bigger or smaller than the more circular ellipse on the front of your paper? It's the eccentricity is higher, isn't it? Because the ellipse in example 1 was 0.6, wasn't it?
Yeah.
So the more circular, the smaller it was. The more flat this one is, the bigger the eccentricity is. And think about this. If I had a circle, wouldn't a squared and b squared be the same value? If I had a circle, because wouldn't a and b be the same distance? So then if I had a circle and I was trying to find c, wouldn't these be the same values here? What happens when you subtract them? You get 0. What's square root of 0? 0. So c would be 0 in a circle. And then when you find the eccentricity, wouldn't it be 0 divided by whatever a is? What's 0 divided by anything? 0. So the eccentricity of a circle is going to be 0. So as the ellipse becomes more circular, the eccentricity starts to approach 0. As the ellipse becomes flatter, the eccentricity starts to approach 1.
Is there a reason in the first example why we didn't put points for a B?
We did.
This one?
We did put points for B. Maybe you missed them. 1, 6, and 1, -2. There you go. Yep. Okay, so any other questions on this before we move on to the last example? All right, so let's moving on. So on this last example, just like the last example in 8-1, you're going to find the standard equation of that ellipse given the following information. And I only have to graph this to the point that I need to find, look at your standard equation. I need to know h and k, which is my center, and I need to know a and b, those 4 things. Don't I get a and b from a is the distance, half the distance of the major axes, and b is half the distance of the minor axes. I can also use c squared equals a squared minus b squared to find any of my missing a's or b's as well. So let's plot this, and we're just going to sketch it. This particular one happens to be mostly in the, well, it is in quadrant 1, and I'm going to go by 2's. So this is 10. So this is 10. And so my vertices are at 5, 0. So that's a vertex, and at 5, 12. And so this distance, and this is a vertex, so let me label that first. So this distance from here to here, isn't that your major axis? What do I know the major axis equals? Well, it equals 2a, right? And in this case, the major axis is what? Vertical? So that tells me what equation I'm going to use. I'm going to use the equation where the a squared is below the y squared binomial. So that's number one. But number two, can't I just take half the distance between those two vertices? So what's the distance from here to here? What's that distance? 12. So I'm going to take 12, and that distance is equal to 2a. So doesn't a equal 6? Isn't that one of the things I need to find? And if a is 6, I can now find my center. Find your center. Your center is halfway between the vertices, or in the middle, however you want to say that. So if the whole distance is 12 and half the distance is 6, count 6 up. Where does that put you? What is this ordered pair right here? That's your center. Yep, so that ordered pair is 5 to the right, 6 up, and that gives you your H and your K. So I have my H, my K, my A. What's missing? B. But look at what else we've totally ignored. Didn't they give you up here your minor axis? What does your minor axis equal? Yes, but what does it equal? 2B. 2B or not 2B? So what is B? Yep, so B is equal to 5. And that's the last piece that I need. Notice I did not graph the ellipse. I didn't need to. I just graphed what I needed to in order to find my missing pieces. So I know that I'm going to use the following formula. 8x minus h squared, and then y minus k squared. Since my major axis is vertical, I know that my a squared goes underneath the y squared binomial because it's got to go vertical, and the direction of the y-axis is vertical. So then the b squared is underneath the x, and then it is equal to 1. So then we're going to just plug in from here. I'm going to move this up here. I'm just going to plug in my values. I'm going to use a template. X minus squared over and so we're going to plug in what we know. I know my center. My H is 5. My K is 6. And then I know that my A is 6. And so my A goes underneath the Y. This is exactly why I wrote it out, so that I wouldn't forget what goes where. It's very easy to put them in the wrong spot. And then I know that my B is 5. So then just do the math. So we have x minus 5 squared over 25 plus y minus 6 squared over 36 equals 1. And that is the equation we're looking for. Wasn't that fun? Is your brain going to explode, Kevin?
No.
Okay. Me too. All right, so we're good with that. So we're just hunting for what we need to find.
So for B, did you get that because it's half of 10?
Yep.
Okay.
Because when they give you your major, your minor axis, it's always 2A or 2B. Well, minor is always 2B. Major is always 2A. And so I just set the 10 equal to 2B, and it's half of that.
Okay.
All right, so then let's look at our second problem. So I'm going to move everything over. All right, so this time they give us the foci and the major axis. Where are the foci located? Along the major axis. So these should all be vertical or horizontal to each other. So let's go ahead and plot them. So I'm going to go by ones on this one. And I'm going to plot my foci first. They say my foci is 0, 3, and 0, negative 3. So that implies I'm on the y-axis. So here's my foci for one, and here's my foci for the other. So when they tell me that my major axis is equal to 10, Jason, what am I going to do with that? Major axis. 2A. Yeah. So because it's a major axis, that's equal to 2A. And so A is equal to what? 5. So I have one piece of the puzzle. So I'm going to go ahead and plot those because that's going to help me find my, well, it won't help me find my center because I can already find my center, can't I? Yeah, isn't my center directly in between the foci? And what point is directly in between the foci? Yeah. So it just so happens that it's 0, 0. So this is my center, 0, 0, which gives me, oh, by the way, my H and my K. If my center happened to be at, like, I don't know, 1, 2, you'd find the distance between the foci, find that distance by counting, and cut it in half, and name the point at where you're at. That's all you have to do. So I have my H, my K, and my A. What am I missing? My B. Well, my foci and my center what does this distance there represent? From the center to the foci, what does that distance of 3 represent? C. That tells me that C is equal to 3. So now I know C and I know A. Can't I find B? So we're going to find B. So we are going to find B. So we're going to use C squared is equal to A squared minus B squared. Now this time I don't know A squared. I don't know B squared. I don't know C squared. So I'm going to have to use A and C and actually square them, unlike what I did the last time. So I'm going to plug in for what I do know. So I know that C is 3, and I know that A is 5. So doing your math, you've got 9 is equal to 25 minus B squared. Are you okay if I add the B squared to this side and then subtract the 9 at the same time? So I end up with positive B squared is equal to 25 minus 9, which is 16. So what is B? 4. So there's my other piece. Now I'm ready to write my equation. So I'm going to move this over just a smidgy. So this was all up here, I guess, step 1, and this was here, step 2. So step 3, because my major axis is vertical, and I know it's vertical because of how the foci are related to each other, I again am going to use that same equation where A squared is below Y. So unfortunately, all these examples all had vertical major axes. So I'm going to use x minus h squared plus y minus k squared. And because my major axis is vertical, that a squared goes underneath the y minus k, and b squared goes underneath the x minus k, and it equals 1. And so then I'm just going to have a template and plug in what I know. So I know that my center is 0, 0 for h and k. I know that a is 5. And I just found b is 4. So then all of this equals, can't I subtract the 0 from the x and the y? If you have 0 in there, you've got to do it. You have to make that subtraction. So then I end up with x squared over, whoops, I forgot my squareds here. Sorry, squared. X squared over 16 plus y squared over 25 is equal to 1. And that is the equation we're looking for. Issues, problems, concerns?